Welcome, everyone, to today's webinar. I'm excited to be here. I hope you are as well. And also, not only to plug Alyssa on those pre-recorded webinars, I tell all our customers not only to plug myself, but Applied Software. There is people just like myself, experts in different arenas of architecture and engineering, and we have these pre-recorded sessions on pretty much every topic for the architecture and engineering aspect of what we do. And there are some incredible webinars from my colleagues there as well as from myself. So please do check it out. It's a really good resource. And Alyssa, I'm glad you had that slide in there. So without further ado, you're here for our continuing education bite-sized BIM 1 hour segment, up to 1 hour. And so I'm going to just read this verbatim. This program is a registered 1 hour learning unit, HSW, AIA, CEU, continuing professional education class. As such, it does not include any content that may be deemed or construed to be an approval or an endorsement by the AIA or any material or construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. So from this point forward, I'm not going to talk about any specific software to meet the requirements of the AIA. At the end, if you do have any questions about specific software that I was alluding to or talking about, ask your questions at the very end, and I'll be very happy to divulge those softwares. So, Applied Software is a registered provider with the American Institute of Architects Continuing Education Systems. Credit earned on completing this program will be reported to CES records for AIA members. Certificates of completion for non-AIA members are available on request. And by the way, Alyssa or Amy, how does an AIA member get their AIA information to us so that they can get this certification?
Rick, I believe there is a widget, and they just fill out their information, and then we send them a certificate. I can check and make sure that's the process, but I think on their end, they see a screen where they can request the certificate.
Awesome. All right. So, folks, if you want that certificate, make sure to fill in your AIA number at the very end or somewhere throughout the presentation. Look for the widget again in our presentation to fill out that information. Make sure to put in your full name as it is in your AIA registration, and it wouldn't hurt to put in your contact number just in case we need to contact you along with your name, number, and AIA number. All right, so without further ado, let's get right to it. The synopsis of this class is to learn about design visualization, simulation, and collaboration enabled by BIM solutions that provide a greater clarity for all stakeholders across a project lifecycle. BIM makes it easier to achieve project and business goals. This presentation will explain how to leverage BIM to articulate and communicate design intent, forecast project cost and schedule for better coordination, and QA/QC. It also sheds the light on space management, assets tracking through analyzing project data, code checking, and simulation project performance. Finally, this presentation will explore the best practices for BIM adoption, implementation, and cloud collaboration, just to name a few things, right? So, in a nutshell, the learning objectives for this class is as follows. We want to talk about utilizing BIM models for code checking, design reviews, space planning, and visual estimating. Then we're going to look at how to leverage a central located model for file sharing as a single source of truth to streamline your process, reduce errors and omissions, and minimize litigation and meet your contractual obligations. Because at the very end, you have to commit and produce a set of drawings and a building, right? Next, we'll take a look at implementing sustainable design technologies to help optimize your building's performance, track building assets, maintain your schedules, and finally, building operations at the very end. Then we're also going to take a brief look at the best practices for BIM adoption, implementation, and cloud collaboration. So, first, let's define what BIM is. BIM is defined as building information modeling. So when you're talking about Revit, I'm sorry, I didn't say that. When you're talking about building information modeling using a software, the key in any of this is the I, the information in the BIM information modeling. The key is the information. It not only has information, but it communicates design intent with all the teams. It provides a more accurate project cost and schedules, creates better coordinated drawings, and gives you the ability to analyze your project data. It simulates project performance and outcomes to more stakeholders. And basically, those are the reasons why you would want to use BIM. So let's take a look at some of the drivers of BIM adoption. First, we're going to start off with taking a look at industry trends. So there are many industry challenges that the building owners face today. These include challenges during project development with an increasing project complexity, easy for you to say, and siloed teams. But it also challenges once a project turnover to the client. Project complexity as environmental challenges, economic pressures, and regulatory requirements increase for the project buildings, and so does the project complexity. Large buildings typically require diverse service teams working from several geographic locations. Buildings themselves are increasingly complex, and information is usually lost when transitioning that information over to the customer. In the end, the project handover, even though the owner may have mandated a driven a BIM process and paid for this asset to be developed, often too much that rich information is lost. The building lifecycle frequently lacks the information that gets sent to the customer. And finally, performance data overload is an issue where building management systems and operation tools produce an incredible amount of information. This information is often referred to as big data. Unfortunately, building owners and their operation teams are often overwhelmed with the sheer volume of real-time information data and aren't able to effectively use it to develop insights and drive actions to improve building efficiency and performance. And on the left, you'll see those things. So first, let's take a look going into industry trends. There are specific influences that are impacting architecture, engineering, and construction and infrastructures. BIM momentum and mandates are required on all projects to be completed using BIM technologies. The benefits of model-based designs are becoming apparent not just to designers and engineers, but to builders and owners. Project complexity is an issue. Projects are frequently large in scale and will increase in time with new advances in building systems. And multiple disciplines and stakeholders need to coordinate and communicate even more so during the design phase and even throughout construction. Explosion of data. This is a big issue that is really affecting a lot of architects and engineers and general contractors because the amount of data on a project is exploding. In years past, we didn't have this so much information, and now with this new model-based information and workflows, the tools generate an incredible amount of new digital information. There's now a growing need to capture and manage and share this data among a diverse and distributed team of designers, contractors, and subcontractors, and now owners. information mobility. Lastly, there's a great need for all of this information to be mobile. This is what I like to call the era of connection. So, how are one of these systems connected? Let's take a look at first MEP systems. Mechanical, electrical, plumbing systems are a huge influence on the adoption rate of using BIM on their projects. Another big driver of BIM adoption has been not only the MEP engineers, but the ability to fabricate off-site. If any of you have attended any of the webinars or events from Autodesk University in the past, you'll see that fabrication is the wave of the future. Not only can we do things smarter and more intelligently using BIM, but fabricating off-site with controlled environments and delivering pieces of the building and then connecting them together on site is the future. Using MEP systems to create not only your design intent models, but then giving the ability to fabricate it off-site is something that will speed up the construction process and reduce and eliminate errors and conflicts that usually fall on the job site. Another influencer on BIM has been virtual reality, or what I like to call VR. So, virtual reality. A building information model allows for better communication of design concept ideas, but with the rapid evolution of virtual design technologies, virtual building environments are becoming easier and more cost-effective to produce. The BIM project can be turned into a truly immersive experience in a matter of minutes or hours with usable technology that is becoming more and more inexpensive to use. I got to tell you, this is an exciting era of VR. I'm using one of these devices, which I'll be happy to tell you about at the end. It runs about $400, and it doesn't need a PC. It's a standalone unit, and you can explore a space of BIM using fill-in-the-blank and fill-in-the-blank technologies, and using that technology to explore a space not only individually, but what's really great is that you can get together with teams distributed around the globe, connected via the internet, and virtually walk through a space. It is mind-blowing. To me, this is really, we're using GoToMeeting and Zoom and all these other communication devices to coordinate and talk over the phone, but to actually talk in front of another person in a virtual environment and point and look at things is taking it up to the next level. And to me, that I got to tell you, I'm super, super excited about it. So another influencer is going to be that more and more owners are recognizing the value of building information modeling as a tool for operating and managing the building in its entire life cycle. Data can be input at each critical stage of the design and building phase of a project. Then, utilizing the project operation and occupation during the building, they can conduct an ongoing facility maintenance and management during the process of design. During the design phase that you're seeing over here, you have the ability to collect data for your project, including your contacts, your facility, your floor space, the typical zones, what type of construction, components, and systems. During the construction phase, additional data can be added on top of this. So now you also have all the things from the design phase, but during construction, the general contractor can have the opportunity to include the assembly, the connections, the resources, the actual job, the impact of changes on the site, and document those changes immediately with a live information model. And you can then, he or she, as the general contractor, can change the attributes of that information. So in the end, you're looking at something that can be used by operation and handover that has everything included in the design and construction phase. As a building owner, this is critical of collecting all of this information. And if you look at it simply, there's really two parts to this. The first part is when you're actually designing it, and the intention of us as architects and engineers, and our intention on creating a building using a set of construction documents. Then the second part of that really works hand in hand is the general contractor and the subs. When they finally build the project, all of that information is now connected back to the construction documents. So now you have a true as-built of what's really there. For owners who are not taking advantages of building information modeling, they're missing a huge, huge opportunity. So how can all of this be put together? You can deliver this also using a cloud-based solution. In the age of cloud-based solutions for everything, there are solutions that allow users in our construction and architecture and engineering to be able to work from anywhere and be linked to what's called a one true source, a one true model. This work shared or central model is not located on any one company's server, but instead located on the cloud. So the next thing to look at in building information, you might have heard of something called LOD. LOD stands for Level of Development. And basically what this means is when you're doing a set of construction documents using building information modeling software, part of the specifications at the very beginning is you want to be able to ask, what is the LOD that we're required to create our construction documents or our building information modeling at? Is it supposed to be at 100? If so, that's just for estimating. Or level 200, which gives you the ability generally to specify it. Level 300, simply put, is I want to buy this thing, this widget off the shelf, and I have just the amount of information to actually go out and purchase it because I can see what it is through my model and then buy it. Level 400 gives you the level of information to actually build it and install it. So think of level 400 as if you were to buy a piece of HVAC mechanical unit, that the mechanical unit, if it was at level 400, would show you all the individual hangers and screws and where to place them. And level 500 is ultimately everything where it gives you the ability to commission it and operate it. So not only at level 500 does it include where each screw goes and hanger, it also gives you all the documentation that you need behind it that gives the owner the ability to manage that object. In this case, let's say that HVAC unit with the operations manual, let's say. So again, level of development is considered of level of detail or sometimes considered level of development. Let's talk about, now that we've talked about factors driving BIM adoption, let's take a look at the state of BIM adoption. So in 2012, the Smart Market Report documented an ROI from specific elements from the BIM perspectives of 4 major participants in the BIM process. In this case, what we are looking at are the 4 participants are the architect, engineer, contractor, and owner. Basically, if we focus on the elements over here that are above 50%, that are hired, that are in red, you can see that the owner saw a huge impact on the sustainability as well as the reduced project costs, project cycle time, increased better communication, project processes, and outcomes on personal productivity that are way above 50%. Elements that improve ROI for the owner are clearly defined in this report. And even though this report was done in 2012 by Smart Market, it still applies today. And I bet you anything, if they did that market research today, these numbers would actually even be higher than 50% because the ROI is now even more evident now for owners utilizing BIM. In contrast, if we look at the response from architects, engineers, and contractors, we generally see an agreement in most areas, although there's less attributed area to an impact on sustainability. Now, what's interesting about this is that mostly because of the interest of business investment standpoint, the design team, rather than the owner, is more interested in increased production. The areas that you see over here that are in red, that are above 50%, give the elements that are most part largely aligned to the architect, engineer, and contractor that provide a element that gives them an increase. So basically, overall, you can see that both from the owner's perspective and the architect's and engineer's perspective, the return on investment for using BIM is amazing because it fits the needs of the architects and engineers for creating a smarter set of drawings. And for the owner, it creates a better utilization for their money. So let's talk about best implementation and best practices for BIM. Pictured over here, you might have seen before, is the famous HOK McClellan curve, which best captures the new shift in effort in why BIM projects are different from the traditional workflows. I'm going to read to you an excerpt from an online article from John W. Lister Architects from his website, because he really explains easily all these different curves. So first, curve number 1 represents the ability to make the impact on cost during a project. You can see in curve number 1, that's in blue, at the very beginning, if you go from left to right, any changes have a huge impact on cost. So you can have the ability to make a more impact at the very beginning. As the project goes towards CA, any changes will have little effect because if you think about it, let's say we were talking about the pour of a slab. If you're looking at making those changes on your construction documents or models at the very beginning, you can have a huge impact without increasing the cost. And if you do it towards the very end, you have a high increase. That is number 2. Curve number 2 illustrates the construction phase and the cost it implicates during the design increase. If you were just to focus at curve number 1 and curve number 2, basically, if you were to make a change in the slab right at the very beginning in schematic design phase, SD, you can have a high impact cost with the ability to make those changes without affecting the cost of the project as a negative impact. The further down the cycle you go, changes during, let's say, construction administration, if you were to make those same changes, the cost and effort would be astronomical, as you can see in the red number 2. So changes later on cost more than if you do them early on. Then there's curve 3, or what I like to call the AutoCAD curve, or the traditional curve followed by a curve 4, my personal favorite, the Revit curve. So what does this all mean? The answer is simple. In the end, it all boils down to dollars and cents. As design becomes more developed, it becomes harder and more costly to make changes to it. Same principle applies to the construction process. So if you're using BIM on a project, you can make huge changes early on in a project without impacting the project cost. The later the changes are in the timeline, the more expensive those changes are. It's an incredible, incredible curve. So earlier in the presentation, we discussed a variety of BIM uses and benefits. As the technology matures and possible uses and benefits are increased, there's a tendency to try to accomplish too much too fast. In the early stages of BIM implementation, a small discrete set of short-term BIM goals should be established, and they should be attainable and measurable. Once those initial goals are met, then additional benefits and goals can be established and pursued as part of an ever-evolving implementation. A BIM implementation is never truly done. Again, a culture of continuous improvement is important to continue to evolve as the technology evolves. Let's take a look at some typical BIM uses. Over here, the ability to capture existing conditions more accurately and to be able to record them is an amazing thing that we can do as a BIM use. Conceptual modeling. Conceptual modeling gives us now the ability to create this conceptual designs and massing using visual programming tools to create these amazing forms of art, is the way I like to think of them, using the technology to drive concepts and parameters to make these changes to a physical element. These make amazing structures that ultimately would never really be designed in the traditional method. This conceptual model of BIM is amazing, giving you the ability to not only design, but then also look at it through such devices as a mobile device to view that information live in a space. Another use is infrastructure. Building information modeling and infrastructure is evident by giving you the ability to not only visualize those things in space, such as a roadway, but also high-rises, and understand the impact of high-rises and solar studies in an environment. You can study the infrastructure online using tools that give you the ability to really manipulate a space in a huge environment and understand its environmental impact. BIM gives you that ability to change information not only for conceptual, but also for infrastructure. Collaboration has come up a few times during this presentation as part of a component of BIM adoption. So let's wrap things up by taking a closer look at collaboration methods and tools. First, you have the ability to not only collaborate looking at different spaces using sketchy and photorealistic renderings, but you also have the ability to do photorealistic renderings using BIM. The visualization not only is something that is aesthetically pleasing, but gives the owners and users the ability to actually see how light, in this case, floods this auditorium space. This simulated environment really is accurate and gives everyone the ability to easily understand a space physically without actually constructing it. Another use of BIM is sustainability. Using this fill-in-the-blank product over here, you have the ability to have an impact on the design decisions of your project that gives you an insight of your building on how it's going to perform. As you see over here on the bottom, you'll see these dials that are in red at 1.41, another one in yellow at 1.22, and a green one at 0.55. And this gives you the ability to see how your building is performing before it's built. And what's wonderful about using this software, because I've used it before, as an architect, I don't have to have a degree in mechanical engineering to understand how to design and change certain elements like the building facade or manipulate something like the percentage of glazing. And I can test it in this environment without actually changing out the fenestrations, for example, in my building information model. I can test it in this environment here first to see if it makes a huge impact on sustainability, and then I can go back into my building information model and make those changes. By simply changing some of these widgets, I can change kind of like the guideline of how my building envelope is going to perform, which makes me a smarter designer and helps me influence my design. To me, this is a phenomenal tool that helps us create better and smarter, more energy efficient buildings. You can analyze such things as energy, solar, and wind. Talking about solar, another use is lighting analysis. Not only can we look at how light affects a space, but we can actually take a look at how lighting is simulated in an environment to see where there are hot spots in an environment. Now, this might be very, very crucial if you're doing something that is very sensitive, like an art museum. You want to make sure that you have a right temperature and right amount of sunlight in a space. And this gives you the ability to analyze this online. Next is visual estimating. To me, this, for a general contractor, is a dream come true because it gives them the ability to quantify exactly and not do a soft cost, but a hard cost to determine how much this project is going to cost them. Quantity takeoffs are exact. Information that is transferred from the BIM information model are transferred immediately into a spreadsheet and back and forth. So any changes in one automatically affect the other. Estimating is now more of a precise science. Let's talk about 3D BIM coordination. What you're looking at over here in green and red is a conflict coordination check where anyone on the design team can utilize these fill-in-the-blank tools to look for collision detection, in this case, before it's built. So I can see if my ductwork, which is in red, interferes with my steel that's in green. Now, you can imagine if this was done digitally ahead of time, how much money we could save. If this was already on site and the subcontractors have this ductwork and they're putting it up in space and they go, wait a minute, we got to stop work because this duct is hitting our beams, it's going to cost money to change it, to lower it, and it's going to spend time of sending that information or request for information back from the general contractor to the engineer or architect. This can all be done and headaches avoided by eliminating those conditions on site by looking at clashes digitally before it's built. 3D BIM coordination, to me, is one of the huge adoptions for using BIM. And then building information management. Ultimately, at the very end of a project cycle, the information that is built into the project, as you can kind of see in these spreadsheets, there's information rich. When I talked about information overload, this is kind of a sample of where you can get so much information you don't know what to do with it. But having the right information at the right time gives the owners the ability to manage their projects effectively and efficiently. So let's talk about BIM planning. A good implementation always starts with a plan. The first step in any BIM implementation is planning. And part of that is to do what's called a discovery. During the discovery, this is a thorough and objective assessment from current conditions, including hardware, infrastructure, staff proficiencies, cultural strengths, and challenges. This gives you the ability to have an overview and capture what your company is doing at that moment in time to understand what their needs are. Next is to establish a desired level of implementation. In other words, let's measure what your BIM goals are. Don't bite off more than you can chew or try to solve world hunger. Identify 4 or maybe 5 at most items and focus on these. Additional benefits and goals can then be established once your initial 4 or 5 things have been implemented and then been stabilized. Once a clear picture of current conditions have been met, then you can focus on future desired states to plan on and attain, which starts at a higher level, and then you can align company goals with tools and processes in order to achieve the implementation and get there in the right direction. Discovery. Establish desired level of implementation, strategic planning, and implementation planning. This includes process maps and information and technology and infrastructure planning and education and training. Ultimately, all of that accumulates in a BIM implementation roadmap that adds critical milestones, estimated timeframes, and metrics for measurements of success. This one slide, folks, over here, the BIM implementation planning, is your guide to basically learning how to make a successful BIM implementation at your company or office. So let's look at collaboration. We've talked about this a couple times, but let's understand the traditional method where they're riddled with opportunities for errors and miscommunication. Data is usually shared between stakeholders on a variety of independent methods, usually simple emails or FTP sites with no control or coordination that can easily cause confusion. Before you know it, all the members of the design and construction team are working on different versions. Some of the critical data is frequently missed, and working on the latest data file is difficult at best to determine. Ultimately, chaos rules. As you can see here, in a typical environment with file exchange, it is very hard to determine ultimately who has the latest, greatest set of drawings. So, a solution for this, instead of having a chaos of file exchange, is to implement something called a cloud-based solution, which is the single source of truth. If you look at this diagram, the single source of truth located in the center replaces all the data information, and then everyone around, starting at 12 o'clock with the owner, then the design team, the company, the vendors, consultants, the public, and infrastructure, and the contractor, all tie into one cloud solution. The single truth of information allows all stakeholders to work on the same set of data, not different versions stored in different locations. This by itself reduces confusion, saves time and money, and ensures a project that is better coordinated. So in summary, we've covered quite a bit in this very, very short webinar. So let's review some of those key points. We talked about how to utilize BIM models for code checking, design reviews, space planning, and visual estimating. We looked at how to leverage a central location for document management file sharing as something that I like to call single source of truth. This helps streamline your project delivery and access from all the stakeholders so that everyone has one location for files. This reduces errors and omissions and minimizes litigation and helps meet your contractual obligations. Then we talked about an implementation for design technologies to help you increase your building performance, helps you track building assets, maintenance schedules, and ultimately facilities operations. Lastly, we talked about the best practices for BIM adoption, implementation, and uses and reasons why you'd want to use cloud collaboration. Now, do we have any questions? And this actually concludes the end of our AIA presentation. So now since we're done with the AI part of the presentation, I can tell you the applications that were used for all of these really center around, as you can imagine, Revit. Autodesk Revit is the core for building information modeling. Part of that collaboration effort that I spoke about as a cloud collaboration solution is called BIM 360 Design. If you hear people talking about utilizing BIM 360 Design, it is a completely new workflow for architects and engineers and contractors to work together on a cloud-based solution. And it's not like anything done before, like BIM 360 Team or utilizing something like Dropbox. If you're interested in finding out more about BIM 360 Design, please reach out to us. Myself and others are experts in using BIM 360 Design and have processes and implementation guidelines and classes that we offer to help you get up to speed quickly so you can start using BIM 360 Design. For energy analysis, you might have seen one of the slides that was called Insight. Insight gives you the ability, Autodesk Insight, to go through and analyze a building while it's still in schematic design, and gives you the ability quite easily change, for example, what type of glazing without physically going through and changing the glazing on your Revit model. Insight through Autodesk is absolutely amazing and really gives you an advanced feature of changing your model without actually physically changing the geometry. And those are just some of the ones that I spoke about during our presentation. So, Amy, we have a little bit of time here. Let's see, do we have any questions from our audience?
Yeah, we have one so far. He says, I work in site design, 2D layout, and 3D grading specifically. Would BIM be useful for me?
Absolutely. Absolutely. Because ultimately, as long as you're generating three-dimensional information, that's where it's going to become very useful. If you're just doing layout, honestly, that is just 2D, let's say you're just using AutoCAD, plain vanilla AutoCAD, then quite frankly, it's not going to assist you. It's not going to help you. But if you're generating topographical information that's in 3D, that has data, that information can then be conveyed to the general contractor, the surveyor, to find out how much cut and fill is going to be needed for better estimation on a project. Great question.